Hello and welcome to the second unit. We are dealing with radicals now. So let's go into this. So first section here, chapter 1, we are getting into exponents. Now, those of you who have been here a little bit, I've taught you this in grade 9, so this will just be a little bit of a review. I'm only going to cover section A here and section B for today, and then the next section will look at something a little bit different. So first law here, basically if you're multiplying two exponents as such, you are going to add your powers. So if we're looking here at x to the power 4 times x to the power of 5, what you're going to do is, in writing this out, I'm going to show you the long way here first. You've got x to the power of 4 plus 5, which is equal to x to the power of 9. Now, you don't need to do this in between step. I'm just showing you where that comes from, but this is what you would do. For something like this, what you would do is you're going to multiply the numbers together, so -2, -3, multiply those together to give you +6. Take the x's, so x to the 2 times x to the 4, you add the powers, so we get x to the 6, and then y to the 3 times y to the 1, we're going to get y to the 4. Notice here, if there's nothing there, that is a power of 1. Be sure to figure that out. An example like this, so all you're going to do is combine each of the terms, times the numbers, times the x's, times the y's, times the z's. I'll leave this as a challenge question for you to give that a little bit of a try. Next is law number 2. So law number 2 is dividing. So it's very similar to multiplying. When you've got two exponents with the same bases and you're dividing, you simply subtract the powers. So here, again, I'm going to do this the long way. So this is equal to b, so the base stays the same. Do not divide the bases. And you're going to subtract the powers. So this would give you b to the power of 4. Again, for something like this, you just do it individually. Do the numbers first, so 12 divided by 6. That gives you 2 over 1, so I'm just going to put 2 for now. And then k to the 12 divided by k to the 6. Subtract the powers, I get k to the 6. And then similarly with something like this, you break it down. So I've got 3 negatives. I'm going to cancel out 2 of them. Those will cancel. The numbers here I can deal with separately. So 36 divided by 48. Factor this out or figure out what you can divide both of them by. You can actually divide both of them by 12. So I'd end up with the negative still there. And I would have 3 over 4. And then let's look at the other part. So looking at the x, I've got x 18 divided by x to the 7. So minus the powers, I get x to the power of 11. Then y to the 10 divided by y to the 9. Minus the powers, I get y to the 1, or just y. And then z squared divided by z squared, those cancel. So this is my answer. That is the second law. You're just subtracting the powers. Third law, I've got a power to a power. So in this case, you multiply the powers. Lots of times, the first law and the third law get confused. When do you add the powers? When do you multiply the powers? You need to be careful with this as you're going through the question. So if it's a power to a power, then you multiply. So for something like this, x to the 4, all to the power of 3, this gives you x to the 12. If you have something in brackets like this, the power applies to everything inside the brackets. So this is the same as -2 to the power of 3 and x squared to the power of 3. So -2 to the power of 3, that gives me -8. X squared to the power of 3 gives me x to the 6. Remember, we multiply, we're not adding. And then this one's trying to trick you. I'm going to leave this as an extension, a bracket and a bracket. That one is something that's a little bit more tricky, but give that a try if you want to. But that's not a question that I'm going to necessarily give you. So because of these three laws, we can actually do a little bit of an extension on these. We can do something that I just did already. If there's two things inside of a bracket and they're being multiplied, I can apply the m to both terms. So for instance, this one, this power of 3 goes to the 2, goes to this 2, and it goes to this one. So I'd have negative 2 to the power of to the power of 3, or cubed, which would be negative 8. X squared to the power of 3 is x to the 6. And y cubed to the cubed is y to the 9. Again, you are multiplying those. You are not, you're not adding them. Then I'm going to leave that one. I'm going to do this one. So what I'm going to do for this, I'm going to expand the brackets first. So bring in all the powers first. So we'd get 3 squared. I'm just going to leave this 3 squared for now. M to the power of 4. N to the power of 6, so I multiplied the powers into each of those, times, now we'll do this set of brackets, so 2 to the power of 3, m cubed to the power of 3 is m to the 9, and then n to the 15, divided by, and then do the bottom, so 6 squared, m to the 4, n to the 6. So now we want to simplify this out. So I've noticed with the numbers, there's nothing that I can do to simplify them. They all have different bases, so I'm going to leave those for now. But notice I've got m to the 4 on the top and m to the 4 on the bottom. Those can cancel. And same thing with n to the 6. Those cancel. And so this one turns out to be pretty straightforward. It's 3 squared times 2 to the power of 3 times m to the 9, n to the 15 over 6 squared. So if, since you're allowed to have a calculator, if you wanted to go 3 squared times 2 cubed divided by 6 squared and figure out how to simplify that, you can. Okay, you have the calculator, you can do that, but I'm not going to do that in this case. The last thing here is fractions. So again, if you have a power with a fraction, you can simply bring that power into everything inside the bracket. So I'm just going to do one example for this one. Let's do the middle one. So the power of 4 goes into everything. So this is going to be 6 to the power of 4, x to the power of 8, y to the power of 12, over 4 to the power of 4, z to the power of 16, w to the power of 8. Notice here, there isn't anything I can simplify. The numbers will simplify at some point. Do not divide 6 by 4. Okay, this is not going to give you anything that works. You can't just divide by that. So make sure that if you're going to simplify, you simplify in the brackets first and then expand it. Okay, so let's move to the next page. Next is negative exponents. So a negative exponent happens when you have a bigger power on the bottom than the top. So you need to deal with that. So we've got here g to the 4 divided by g to the 8. If I did the steps explicitly, so I subtract the power, I'd get g to the power of negative 4 when I go 4 minus 8, which, to get rid of that negative power, I bring it down to the bottom, so it becomes a positive power like so. You do not need to do that negative power in there. You don't need to apply that step. And the way you can remember this best is looking at which of the powers is bigger. And that's where it should be in the end. So here, I've got 8 over 12, so I can simplify that, divide them by 4. So I'd have 2 over 3. And then k squared divided by k to the 7. I notice k to the 7 is bigger, so I'm going to end up with the k on the bottom, and the difference is 5. So you can go through and continue those questions as such. And then continuing on, again, law 4. It's not technically a law. It just occurs based on what happens because of a negative power. It just means this flipping motion. So if you have a negative 3 here, I'm going to take this and flip it. Or negative 3 here, I'm going to take this and flip it. So something simple like this, it's just going to be 1 over negative 2 to the power of 3, and then expand that out, you'll get 1 over negative 8. Stuff like that. Again, this applies to the whole fraction, so 1 over 2x to the power of positive 3, which if I expand that is going to give me 1 over 8x cubed. So there's two ways I can go about doing a fraction like this. I'm going to show you both ways. One of the ways is you flip the fraction first and then bring the powers inside. So actually I'm going to simplify inside first to make my life easier. So I'm going to end up with 1 over 3, simplifying this, y cubed divided by y. This just gives me y squared, and z squared on the bottom to the power of negative 4. If you can simplify in the bracket, do that first. That'll help you later on. So I'm going to flip the fraction first. 3z squared over y squared, all to the power of 4, and then expand the power in there. So this will give me 3 to the power of 4, z to the power of 8, divided by y to the power of 8. And there's my answer. So you can do that first. You can flip the fraction first. Or, in this case, I can bring the powers inside first. So if I do that, I get 2 to the power of negative 4, y to the power of positive 12, because negative and negative cancel, divided by 3 to the power of negative 4 times z to the power of positive 8. So notice here, by doing the expanding inside first, I actually save myself a little bit of time because I'm not flipping and then having to flip again. The only numbers I need to flip here are the numbers. So I get 3 to the power of 4 times y12 over 2 to the power of 4 z to the power of 8. So that's that one. Again, I'm going to leave this one as a challenge question if you want to give that a go and see if you fully understand it. So that is the first section. I'm going to leave it there for now. I'm going to continue on with C and D next class.